Hello students, in this video we'll begin our discussion of covariant differentiation. Let's be given a contravariant tensor A capital I. This means that its transformation law satisfies the following, that AI is A bar, right, tilde for components J, and then dxi dx tilde j. Okay, that's the transformation law. And now let me take this equation over here and differentiate with respect to xk. So differentiate with respect to xk. So I'll have dai dxk is going to be what? Is going to be, well, it's going to be dA tilde j dx tilde L dx tilde L dx tilde k by the chain rule times dxi dx tilde j. That's what we would expect to happen if we had one contravariant and one covariant component. I'd have this transformation law. So that would be beautiful if this was true with nothing else. That would say that dAI with respect to dxk would form a mixed 1-1 tensor. If that was all that was left. However, we have to use the product rule. So we get extra terms over here. We get plus A tilde j. And then I have to differentiate this with respect to k, right? So that's going to be a d squared xi. And then a what? Then a d x tilde L dx tilde j, and then a dx tilde L dx k by the chain rule again, right? And so we have these extra terms over here, right? And those terms are the non-tensorial part of this differentiation process. So this tells me that this whole thing, so the dAI dxk is not a tensor. Unless this term over here vanishes, as it would if you were in Euclidean space where the coordinates are affine, so you would have no second derivatives with respect to the coordinate transformation. However, in a non-affine transformation, this will persist in general, okay? And now we need to recall how I can basically construct a different type of differentiation in order to respect that will become a tensor, respecting the fact that I can absorb these extra terms into a compact form, right? So let's recall, we've proven previously that the Christoffel symbols transform in the following way. If I do gamma of P, Q, R tilde, this is going to be gamma of I, J, K, and then dx tilde R dx K, and then a dx tilde dx I over dx tilde P, dx J over dx tilde Q, plus, we'll have a Gij. There's no Jij in this one. Just going to be what? Just a partial with respect to x tilde r, partial x n, and then d squared x n dx tilde p dx tilde q. Okay? And so that's the transformation law for Christoffel symbols. And so now what I need to do is I'm going to actually do a multiplication of both sides of the equation by something. What am I going to hit it with? I'm going to try to get rid of this term over here so I can isolate the second derivatives. So what I'm going to do is I'm going to do a dx m dx tilde r to both sides of the equation. So we'll do that both sides. So over here we're going to put a dx m dx tilde r, so there's a contraction over here, right? All right, and so what will happen if we do this? These terms over here will generate a delta mn, okay? And so I'll replace the n's over here with an m, okay? Excellent. And so our relationship, and then I can actually use this to solve for the second derivative. So therefore what we'll get partial what? Partial squared xm partial x tilde p x tilde q is equal to x partial xm partial x tilde r gamma tilde r pq, beautiful, and then minus these terms over here. So minus, remember I have to hit these terms with the partial xr terms as well, right? So let's see what we're getting over there. Minus gamma I j k partial x. Well, let's just do it right now, actually. So what will happen over here when we do this contraction? When we do this contraction over here, now I have this term over here, and then this term over here. What will that give us? When we do those two terms, we have a delta km. So that k is going to turn into an m, actually, like so, okay? Excellent. So now I'll have a partial xi, partial x tilde p, partial xj, partial x tilde q, like that. And now I have this second derivative relationship, okay? Excellent. Now we want to fill that into our problem, but our problem has different indices, so we're going to have to change. I like to use this over here. I'm going to change the indices. So let's do that, and we'll do it very slowly. So what would partial squared xi partial xl tilde partial x tilde j be? It would be what? Well, my m is now I, so it'd be a partial xi over r. There's no r is a dummy index over here. Partial x tilde r gamma r. My p and q are j and l, like that. Those are tilde components. And minus gamma of m. We know that m is equal to I. And then the I and j over here are dummy indices, so I have to actually change them to a and b. Okay. Partial x a partial x b over partial x tilde p, but my p is l, x tilde l. Partial x tilde q, but my q is now j. Okay, excellent. So now I've just used this. All I've done is I've just done one intermediate step over here in order to compare the indices. Now I'm going to fill this into my formula over here. So what I'm going to do is I'm going to have a partial ai over what? xk. And then I'm going to have a whole bunch of other terms is equal to partial a tilde j partial x l tilde partial x tilde l partial xk partial xi partial x tilde j plus aj tilde, like that. And then partial squared xi, I'm going to fill in this whole formula over here. Then partial xi partial x tilde r gamma tilde r l j, like that. Beautiful. And then I have a minus gamma ab, dummy indices, I partial x a partial x b over partial x tilde l partial, and those are not the same, partial, there's no bar over there to be like that, partial x tilde j, like that. And all these things are hit with a what? Partial xl, partial x tilde l, partial x k. Okay? All right, so let's look at them. We can do some simplifications over here. The first simplification we're going to do is look at this over here. I'm summing over this term over here, and this term over here is going to give me a delta lk, right? So that's going to be a delta lk. I'm sorry, excuse me, a delta ak. That's a delta ak. All right. And so that delta ak is going to turn this a over here into a k. Excellent. And let's pull that on the other side of the equation now, right? So now, if I rearrange this, what are we going to get? So if we rearrange this, do it slowly, I'm going to take these terms over here, these negative terms, throw them on the other side of the equation, right? So this will tell me what? This will tell me that partial ai, partial xk, add these terms over here, plus a tilde j times what? Times gamma I k b, all right? And then partial xb, partial xj, partial xb, partial xb, partial x tilde l, tilde of what? X tilde j, excuse me, right? So that gives me those terms over there is equal to what? These expressions are equal to, now I'm going to factor the two things these things have in common. They have a partial what? So these terms over here and these terms over here have a what in common? They have an I and an R, and the J is being summed over. So this, I can replace that R with a J, and that would be consistent with those terms over there. And then XLK. So these terms both have a partial tilde XL partial XK. these terms also have a what? These terms also have a partial xi, partial xj, partial xi, partial xj, with the tilde on the j, right? Then they'll have a what? Then they'll have a gamma over here. I've replaced this dummy index with r with a j over here, and that dummy index j can be replaced with anything I wished it to be, right? So I replace it with a, in this particular case, with the j still, right? All right, excellent. And now what? And so we have all the terms that we want. And let's make sure we are all on the right track over here. Where's my r? My r over here. There's no r over here, so this r over here is actually a what? So we have caught an error too. So what have we done over here? I have a delta mn, and so that's gamma r over here. Where's my gamma r? So my gamma r was hit with that, and I'm summing over r in that case. So I'm summing over r over here. Excellent, so those are summed over r. That's a dummy index over there r, no problem. All right, excellent. And now what can we do? And so now we have the delta LK, the gamma delta RXJ tilde, right? Perfect. And then we have the what over here. So what's left over here is going to be these XL terms, XK terms. And so what we can do is what we're going to have over here. So we're going to have an XL, which we pulled out XK. And then we're left with a what? We're left with these terms over here, the summed up terms. Perfect. And so my summed up terms look like this. I'm summing over the lower index. Good. An L and a J, and so perfect. We have a, just keep all our indices straight. So we got that, we have these terms that are left over. Okay, so then the terms that are left over are going to be an A tilde J. I'm going to call that something else. Let's call that J, maybe like a Q. And I've called that J Q, so that becomes a Q over there, right? So this becomes an R tilde, R tilde, R tilde, AQ, A tilde, LQ, and then I have an R over here, and that R is turned into a what? So that R turned into something different. I pulled out an XIJ, that turns into a J. Beautiful. Okay, so that balances out with that J tilde in the denominator over there, so I have a J and a K, perfect. And then what? And then plus the terms that just have this term over here, so I have an AJL, right? So this is going to be a partial A tilde J, and then a L. Go over there, X tilde L. Excellent. So now I'm summing over L, and I'm summing over, we're summing over these L's over here. And we have all the indices correct. We're summing over J over here. So I sum over the dummy index J and then the I. So I have an I and a K and an I and a K. Perfect. So I have the I and then the K in the right order over here. And then, perfect. And so what does this show over here? This shows that this quantity, so we have this tensorial relationship now. And so this implies that the expression delta K of AI, which by definition is partial AI, partial XK, plus what? And then the last thing we need to do is we need to change this thing over here, right? But now I can use the what? So now the last thing to do is to take this and observe that this is really what? This is really partial AI, partial X, partial XK, plus I can turn this into a regular what? I can turn that into a regular A, what can we change this into now? The tensor relationship, I can turn that into an A sub B. So plus gamma I K B A, B. So that's just plain like this. I've used the contravariant property over here to do that, right? Excellent. Using this contravariant property. And so that says that plus, if I look at it, plus gamma I, K, B, A, B is a mixed 1-1 tensor called the covariant derivative of what? Of AI. Excellent. What this gives me now is this gives me a tensorial way of differentiating a contravariant vector field. We can use the same principle to figure out how to differentiate a covariant vector field. The only thing which you'll see in further videos is that the sign of this expression over here changes, and we get a slightly different transformation law as well. But the general principle, this principle will work in general using the fact that the Christoffel symbols transform in a particular way with respect to the second derivative. So in further videos, we'll see how to do covariant differentiation of tensors of higher order, how to do contravariant differentiation simply by raising the index over here of the covariant differential index, and we'll see how to generalize these things to higher dimensional tensors, which will allow us to do intrinsic differentiation, differentiation on curves, and Lie differentiation. Thank you very much.